In this video, I just want to show you some things you can do on your calculator. There seems to be a little bit of issue with having the calculator open at the same time as I'm doing the notes, so I just thought I'd do it separate, and that way you can view it at your discretion. So back in 5.3, we had the problem where we knew that n was equal to 6, and x was equal to 1, and p was equal to 0.25. And it's okay. I showed you how to set up your binomial probability with 6, choose 1, and then doing the whole formula. But the way you type it into your calculator is this way. So that NCR formula is in a menu, and to get to it you need to go to math. But before that, whenever you have a combination or a permutation, you want to type in that first number in first. So an example we did, part A, where n was equal to 6, I would type in my 6 first, and go into math, arrow over to PRB. And if you notice, the third choice is your NCR. And then I type my X value after that. Some books call it R, some call it X, but for us we had 1 success out of 6 trials. And then for the rest of the binomial formula, I would say 0.1 raised to the first for the number of successes I want, or no, I'm sorry, this would be 0.25 was the probability, raised to the first, and then 0.75 raised to the 5, which is the 6 minus 1. And you could type 6 minus 1 up here, and the calculator will take care of it, but I tend to just do that part in my head. And that was the 0.3559 we got last time, and we got it rather quickly. So if we tried it with part B, we had 12 trials. I go into math, PRB, number 3, for that NCR. We're interested in 10 successes. The probability of a success is 0.8 raised to the 10th. And the probability of a failure is 0.2 raised to the second. Oh, I did something wrong. It doesn't like that symbol there. Still doesn't like something. Let's just start all over on that one. So 12, math, PRB, number 3, 10. Something tells me I left out my multiplication here. 0.8 raised to the 10th for the number of successes, and 0.2 raised to the second for the number of failures. And that's where we got that number from. Now the next thing I want to show you is when we did the problem with the student guessing. There were 12 questions, and we were interested in exactly 8 were right, or at least 10, or at most 3. And I was pulling those numbers up pretty fast. And here's one way you can do that. Your calculator will actually calculate binomial probabilities for you without even typing in this whole formula here. So actually, let's go back to the problem we just did, the 12, n equals 12, x equals 10, and p equals 8. Right here above your VARS button, which stands for variables, you have DISTR for distribution. If you select second and distribution, you get this list. It says normal, inverse normal. If you arrow down, there you'll see binom PDF and binom CDF. When you're looking for just an individual value, choose binomial PDF, which is the probability distribution function. And press enter, and that brings it to the normal screen. Now what you have to remember, and you don't have to use this function if you don't want to, but if you like to do things a little bit faster, this is helpful. You have to remember the argument. And the argument means the order that I put the numbers in. For binomial, it's n first, followed by a comma, and then the value for p, followed by a comma, and then the value for x. So for the one we just did, n was equal to 12, comma, the probability of a success was 0.8, comma, which is right here above your 7. And the number of successes we were interested in was 10. And if I hit enter, it gives me the exact same answers I got before by entering it as in the equation form. So that's there for you if you'd like to use it. The other thing I'd like to show you is when we had to do at least 10 and we were summing up several probabilities, and we did at most 3 and we had to sum up several probabilities. There's a fast way to get those probabilities. If you do your Binomial PDF again, so we go second DISTR, which is above your variable button, and arrow down to Binomial PDF. We don't want CDF, not just yet. So if I put in 12 for the number of trials, comma, 0.8, or in this one it was actually 0.2. This is the true-false question. 0.2 for the number of, or the probability of a success. And if I don't put the number of successes I'm interested in. So 12 is the number of trials, P is the number, is a probability of a success, but if I just leave the rest of it blank, what it's giving me is all the probabilities for the entire distribution. An easier way to see that, or what you can do, is arrow through. So this first one is the probability that x is equal to 0, meaning I don't have any successes. The second one is a probability of 1 success, and then 2 successes, and 3 successes, and you can keep arrowing back. And if you notice, those match what we wrote down. So those are those individual probabilities. And that's a faster way to get them than setting up the equation for probability that x equals 0 and probability that x equals 1, and for 2 and for 3. The last thing I want to show you, and a lot of this is if you want to use it. You don't have to use it. You can still do things kind of the long way or with the equation. There's no shame in that. But if you're very comfortable with your calculator, you might choose to do things this way. Just as we saw all those probabilities for the entire distribution, it was a little bit hard to scroll through and see everything. You can instead put that in your list. So if you go into Stat, Edit, and notice I have some values in my list 1, I'm going to press my up arrow to put my cursor up on the list name, and I'm going to type in my distribution here. So if I go second DISTR, I'm going to go down to binomial again. And I still want PDF. And let's say we're still talking about that multiple choice question for the stat student. So there were 12 questions to choose from, and the probability of getting a single question right was 0.2. And again, I'm going to leave off the number of successes. If I press enter, what my calculator does is populate my list with all the probabilities for the entire distribution. So this first number is the probability that 0 are right, and then next is the probability that 1 is right, and then 2 are right, and 3, and so forth. So that just makes it a little bit easier to read all those values. You can jot them down to sum them up, or and there's some other ways to do that, but just want to show you those kind of tricks of the trade. It's really handy, and it makes use of all the power that this calculator can do. If you have any questions about your calculator, how to use it, please certainly by all means let me know. But hopefully that'll get you moving through your homework a little bit faster.